Hello guys, good evening. Welcome to the session. Today we will discuss about data modeling for AI systems. Let us start. Data modeling for AI, artificial intelligence. Before understanding this, first of all, we should talk about data modeling. Data modeling means is nothing but you organize the data according to like end application or end users usage and requirement. Let us see some systems that are designed, and within the systems you will organize the data, keeping the usage and the availability of the data, fast responses, keeping all these factors in mind. Database engineers or data engineers, data architects, they'll apply data modeling on different variety of platforms. Let us understand this. Okay, data has evolved. Not only the data, the applications which we built using this data has evolved. In early 1970s to 1990s, it's OLTP era. And after that, we started analyzing the data. And then data grew more and more. We call it big data and design new solutions to store that big data, to process that big data. Now we are having AI models. And the systems which we have built, like databases, data warehouses, data lake houses, which we are using so far to handle the big data, are they enough for AI? Or we need any other models, other techniques for this AI? Let us understand in this class. Okay, modern AI applications don't replace traditional data models. They are built upon them only. We will understand the evolution. First, we will start from OLTP. See, the popular example we can take is e-commerce, because OLTP systems, they are used by applications. And we know all the applications, the e-commerce applications. If you are open your phone, you have a lot of applications installed, and all these applications are interacting with the database in the backend. When you try to log in into some application, that application will read your data from the database, or you register to your application, your details will be saved in the database. And let us take one such application, e-commerce application, and how its OLTP system, that means online transactional processing systems. And usually we call these OLTP system, or we will design these OLTP systems using relational database services. Most of them, like MySQL, Postgres, Microsoft SQL or SQL Server, structured databases in short. Let us say we know how a e-commerce site works and what kind of data application has to frequently fetch from the database. Let us say it should have a customer, product, orders, and order items. These kind of tables are designed in the backend. And whenever order is placed, order data will go into orders table. And how we are sending it: order ID, customer ID, order date, and the foreign key. Customer ID is referring to customers. Okay. And then we separated the customers because let us look into products. See, um, these separation we call as third normal form. Third normal form model ensures data integrity. First, observe this orders table. I can keep all the data like orders plus ordered items together. See, in orders itself, I can have the quantity what a product has been ordered, and then how much of the quantity has been ordered, and all these I can save in one big orders table, which I'm saying like one normal form. Data will be like how it got generated in the as it is way. You're saving in your orders table. You're not doing much. That then it is one normal factor. In this one normal factor, what is happening? Every time, let us say you want in orders table, quantity, product ID, order ID. Other than that, if I also keep product details, customer details also here. Customer ID is fine, but every time if I want to put all the details, that is not only customer ID and other details like name, email, city, then it's unnecessary space, usage of space, and also there might be chance of duplications, especially when you want to update certain things like price. I want to update. The e-commerce site want to give some discounts. I want to update the price, or there is increase in price. Then if I maintain everything in one table, which is one normal factor. One normal factor means you are having the data only in one table. Two normal factor means more than in one place. In couple of places you have the data. Three normal factor, in three places you have the data. Why you are doing that? Because at at least in one place, that is in one table, you want your data to be unique. For example, product ID in orders table cannot be unique, or order items. Here, product ID, multiple customers will order the same product. So, product ID cannot be unique here. We need a table where product ID can be unique. So, whenever we want to make updates, like updates in prices, or we are bringing new categories, we want to shuffle some product IDs to new categories, or change in name, then I can apply those changes to this products table. This is like main table, and you see the orders table is referencing to customer, and order items is referencing to products. From the products, it's getting the data, foreign key. So whenever an order is placed, we are not just sending all the details coming from that event into the system, OLTP system. We are splitting that data. From that event, when got generated from the application, that event has data like this: order placed. Then application sends data something like, it generates the data something like order ID, of course, and who placed the order, customer ID, and product ID, quantity they have placed, and payment method, category of the product. So all these kind of data will come. Now instead of just putting it as it is in the OLTP system, how the data is written: order ID, and then customer ID, and then date also, of course, order date will go and sit in this table, and quantity, product ID will go and sit in this table. These two tables, of course, they have the data, and also they are referencing to these. Suppose tomorrow if there is customer like change in email, then we are creating a reference instead of saving here. Only I should take care that customer ID should be unique in this table. So we have made this primary key. And other tables reference to this table. Whenever there is changes, they can easily adapt the changes. If you keep it in one single table, it is hard to make changes. Okay, this OLTP system is good when for read write transactions. Application. Tomorrow, if I cancel any order, I mean user cancels any order, if they want to look into their purchase history, if they want to know how many products they have ordered so far, these kind of things app can read from this OLTP system you have designed, which is very efficient and easy to manage and avoids duplications, maintains strong asset properties because you are following 3NF. Here, data modeling is 3NF. Your platform is database. It could be Postgres or MySQL or any other relational database service. You are following 3NF, three normal forms. So, application without much issues, conflicts can make read, write, update, sometimes delete also, delete. All these operations it can do. And it does these operations very frequently, very often, very rapid. And these databases are designed to handle that fast transactions. For e-commerce site, in this scenario, databases are suitable. But that is not enough for businesses. Just a database, an application, that is alone not enough. So they also want to understand how businesses are happening, like making analysis of the existing from the existing data and using the existing data and current data, predicting or forecasting the future. What could be the future sales of next year or next month or next quarter, and what are the patterns, KPIs of business happened so far. So these kind of analysis people want, and that is where we started using data warehouses. Now we shifted from databases to data warehouses for this purpose. Databases are still there. Yes, they're still there. Application is still using the database. But I want to do analytics now. And I cannot put my analytics load on database. So I'll use data warehouse, and that's where data warehouses came, where they will have all the data, all the historical data. That's why the name data warehouse. And they also run on like much more like in terms of infrastructure, more infrastructure in terms of compute as well as storage. They run on clusters. And these are not designed for only giving you that fast, quick responses for your transaction alerts. I mean, transaction queries, sorry. They're designed for online analytical processing, deep analytical queries. I want to find out top customers of all the regions of this business, category wise. Then obviously I cannot run this query on database. It might hang up the database. Data warehouse, data lake house is the right place. So businesses started to copy the data that was generated by the applications and from various platforms. They put in database wherever it is necessary, and from there moving to data warehouse, copying to data warehouse. Some data like log data, some data might come in like real time monitoring data, third party data that will be directly saved in data warehouse. Transactional data, it has to be in database, like on some schedule daily they'll move to data warehouse for further analytics, for creating leaderboards, dashboards, forecasting, these kind of analytics. And that is where data warehouses, data lake houses are used. Now, depending upon the end user usage, here we will plan data modeling. See, one popular data modeling used in data warehouses is star schema. Now the platform is data warehouse. I should organize the data in the data warehouse so that end users can effectively make use of data. In star schema, what we are doing, we are separating the data into facts and dimensions. It will be easy for analytics reporting when you have data like this. Again, it appears slightly like 3NF. You're separating facts and dimensions. It has a similarity but not exactly same. If you say sales data, this is example query. In the sales data, I'll save all the sales in fact sales table. Of course, in sales data, I'll be having customer data, product data, date data. I'll separate the dimensions. When I want to query, I'll query like this. See the product details every time. I need not like save for every sales data. If I separate, while querying, I'll join and get the data whenever is needed. At data warehouse level, we have star schema, which is like same concept like 3NF. An OLTP we say 3NF. Here we have star schema, not exactly same, but they appears to be similar. Both are into splitting the data. Here we will say split data into facts and dimensions. And we have many other also. In data lake houses, we have this popular data modeling technique called bronze, silver, gold, which is called as medallion architecture. Whenever you want to store raw data also, like data is not coming from structured systems, something like click streams, log data, social media data. First put it in bronze layer, clean it, and then in the gold layer you aggregate it or you split it into facts and dimensions. This is one way. Data lake houses are nothing but which can save data in file format as well as tables. This is one more popular data modeling technique we use. Now, so far what we discussed, we understood that when applications use has to use the data for read write, then we will use OLTP databases. And for strong ACID properties, we will split tables as much as possible. Like at least table should have, data should be unique in one table. By doing this, it offers strong consistency. That is in databases. Data warehouses, when you want to do analytics on your data, like reporting, creating dashboards, and also applying ML, forecasting algorithms, then we will move data to data warehouse or data lake house. I have two examples here for analytics dashboard and customer journey tracking. You can keep either in warehouse or lake house, anyone. And in that platform, we will follow data modeling again, which is nothing but organizing your data. You can save your data in three layers like bronze, silver, and gold. And you can save your data by splitting facts and dimensions. You can apply both hybrid model also, star schema plus medallion. It all depends upon who is going to access data. Accordingly, you will apply your data modeling. Okay, this is analytics and above we have discussed about transactions. Now we have lot of AI applications. AI LLM based applications like ChatGPT, Perplex, and we have so many AI applications. They are using LLM, which is large language method, and RAG. These two are like behind almost all the popular AI applications. Now, these applications uses same databases or data lake houses. Obviously, databases is not a right fit here, um, because they want to access huge amount of data. And already for analytics purpose, we are bringing data to data lakehouse or data warehouse. And how data is accessed from these databases, data lakehouses, data warehouses. One method is querying using SQL. Another method is using Python. Python or any other language, not only Python, Python or any language, PySpark, using connectors, you will connect, especially when you want to move around the data to build ETL or ELT, you will use this. Data scientists use Python anyways to build the models forecasting. Data analyst will use SQL to create the dashboards. Now, does AI applications like ChatGPT use the same querying, same method, same databases, like the same data modeling techniques will be helpful for this AI or LLM? We will discuss that. Actually, this large language model will not query the data, will not read the data. Like using any language or using a query, it will not fetch the data. It is already trained with all the information. And using that LLM, you are going to get the results um, for whatever you give. See, this LLM is something, a model. You are trying to get some information from ChatGPT. And already that information is available on internet. But you cannot go through internet and read all the pages, all the websites where the info is available. LLM will do that for you. It has already read the internet, and whenever you ask a question, LLM gives you that. I mean, it already has trained. That model has info with it in its memory. It will give you the answer. But if you want to build an AI application for your business, your business's data is not available on internet, then you have to create a LLM which has already read your business's data, and it should be able to answer any question related to the business. So LLM needs permission to read the data, and that is provided by RAG. Okay, let us understand this first. Now here, your regular tables, facts table, dimension table, which we created in data warehouses, or the orders table, products table, orders ID table, which we created in databases, are not directly used by AI applications. They will create a special tables which has document metadata and document embeddings, which are called as vector tables or vector based tables. You see how this works. This is an vector database created in Postgres table. See, this Postgres table has an extension, vector, PG vector. Add that extension and you create a table like doc embeddings. And what you are creating, like document ID, which is nothing but like a page number, and chunk index. Now, from the data warehouse which you have designed or from the database, you are getting a chunk of data, or you save the index of that chunk of data. And let us say I am asking some question related to electronics. Now, electronics chunk index is available here. My LLM model, RAG and LLM model, will make use of this data and provide me the answer. So you will be having chunk index and one more thing called as embedding. vector, chunk text, and other metadata, and primary key. So like this, you will create a vector-based tables. We will understand how this will work. Let us take an use case. Uh, Let us business problem is creating an AI assistant. Just give me a minute. Sorry, guys. Yeah. By combining transaction data, analytics, and natural language understanding. So the data which we have so far in databases and data warehouses. When customer queries something like this, which wireless headphone under $200 have best reviews and are currently in stock, and they are ready to ship to New York within 2 days. When customer asks this kind of questions to AI assistant should be able to give the right response, and the response is given by LLM, large language model. That LLM should be built on your data. What data? Transactional data, analytics data, and of course few algorithms like natural language understanding, uh, which reads the reviews, understands the reviews, and to understand which data is currently in stock. Obviously it will be available in transactional databases, and which can ship in 2 days to New York. That also will be available in transactional databases. So based on this data so far, LLM model should understand and it should give the response. So for this, you are using multi-layer data flow. OLTP layers, data warehouse layers, which we already built, businesses has already built. They will be like that only. On top of that, we are creating a search layer, a semantic search layer through reviews to understand sentiment. Okay. And then LLM RAG layer, which results into natural language process. And finally, it gives the response like this based on your requirement. It is recommending this headphones. So now we don't need a new platform. We need only extensions to the existing data platforms, either to data warehouses or OLTP layers. They have to support a search layer. What this search layer is having? This search layer is having these kind of embeddings, right? Embeddings or chunk indexes will be created. Now the search is asking for headphones. Now immediately your search layer knows that headphones belong to electronics section. So it has a chunk ID of electronics. It will search. All these will be done by RAG. It will index towards that electronics chunk of data. And that data will be used by your LLM, and it provides the answer, right? And see here, convert the query to embedding and find similar reviews. Just give me a minute, guys. Sorry. Yeah. We were converting query to embedding and find the similar review. Embedding is nothing but you are converting the real world objects, like in the search or the customer query, has the real world things, real world objects. So some keywords like electronics, price under $200, and they want best reviews, and they're also saying currently in stock. These should be converted into embeddings, which are nothing but numerical data. Numerical data, something like chunk IDs, where they can get the data, right? For here, what we are doing, we are selecting the product ID, review text, both, and mapping the embedding. So this is like a new way of data modeling, creating a vector search layer on the existing databases and data warehouses. For AI applications, we will create a vector search layer. Yeah, that is about data modeling for AI.